The AES algorithm stands for Advanced Encryption Standards. It is a specific for the encryption of electronic data established by the US National Institution of Standards and Technology in 2001. AES is widely used today as it is a much stronger than DES and triple DES despite being harder to implement. AES is a block cipher. The key size can be 128, 192 and 256 bits. Encrypts data in block of 128 bits each. That means it take 128 bits as input and outputs 128 bits of encrypted ciphertext as output. AES relies on substitution permutation network. Working of cipher. AES performs operations on bits of data rather than in bits. Since the block size of 128 bits, the cipher processes 128 bits or 16 bytes of the input data at a time. The number of rounds depends on the key length are 128 bits key 10 rounds, 192 bit key 12 rounds and 256 bits key 14 rounds. Let us see how we create a round key. A key scheduled algorithm is used to calculate all the round keys from the key. So the initial key is used to create many different round keys which will be used in the corresponding round of the encryption. Each round comprises of 4 steps: subbytes, shift row, mix columns, add round key. The last round doesn't have the mix columns round. The subbytes does the substitution and shift rows and mix columns performance the permutations in the algorithm. In subbyte steps, we implement the substitution. In this step, each byte is substituted by another byte. It's performed using a lookup table, also called the S box. This substitution is done in a way that a byte is never substituted by itself and also not substituted by another byte, which is a complement of the current byte. The result this step is a 16-byte 4 into 4 matrix like before. The next two steps implements the permutations, that is shift row and mix columns. In shift row, each row is shifted a particular number of times. The first row is not shifted. The second row is shifted once to the left. The third row is shifted twice to the left. The fourth row is shifted thrice to the left. Same in the mixed columns. The step is basically a matrix multiplication. Each column is multiplied with a specific matrix and thus the position of each byte in the column is changed as a result. This step is skipped in the last round. Add round keys. In this, the resultant output of the previous stage is XORed with the corresponding round key. Here the 16 bytes is not considered as a grid but just as 128 bit of data. Decryption process. The stage in the round can be easily undone as these stages have an opposite to it, which when performed reverses the change. Each 128 blocks goes through the 10, 12 or 14 rounds depending on the key size. The stages of each round in decryptions are add round keys, inverse mix columns, shift rows and inverse subbyte. In the inverse mix columns is similar to the mix column steps in encryption but differs in the matrix used to carry out the operation. In inverse subbytes, inverse S boxes is used as a lookup table and using which the bytes are substituted during decryption. AES instruction set is now integrated into the CPU to improve the speed and security of applications that use AES for encryption and decryption. Even though it's been 20 years since its introduction, we have failed to break the AES algorithm as it is infeasible even with the current technology. Till date, the only vulnerability remains in the independent implementation of the algorithm. Coming to the characteristics, AES has a key of 3 lengths which are of 128, 192 and 256 bits. It consists of 10 rounds of processing for 128 bits key. It provides high security and it can prevent many attacks. It does not have any copyright, so it can be easily used globally. It is flexible and has implementation for software and hardware. Advantages of using this algorithm is it can be implemented on both hardware and software. It is a very robust algorithm. It provides high security to the user, and also it provides one of the best open source solutions for encryption. And also there are some disadvantages regarding to this algorithm. They are it is difficult to implement when performance have to be considered. It requires many rounds of encryption and it is hard to implement on software and it needs much processing at different stages. AES and DES are both examples of symmetric block ciphers but have certain dissimilarities. Let us see the differences between AES and DES. In AES, the date of creation is 2001 and in DES the date of creation is 1977. AES algorithm is a byte oriented algorithm and DES is a bit oriented algorithm. The key length can be 128 bits, 192 and 256 bits in AES algorithm, and coming to DES the key length is 56 bits. The structure is based on a substitution permutation network in AES algorithm and the structure is based on then Fischl network in DES algorithm. The design rationale for AES is open and the design rationale for DES is closed. The selection process for this is secret but accepted for open public comment. The selection process for this is secret in DES algorithm. The rounds in AES are byte substitution, shift row, mix columns and key addition. The rounds in DES are expansion, XOR operation with round key substitution and permutations. In AES algorithm, we can encrypt 128 bits of plain text, while in DES we can encrypt 64 bits of plain text. AES generates ciphertext of 128, 192, 256 bits and it generates ciphertext of 64 bits in DES algorithm. AES cipher is derived from an inside channel square cipher. DES cipher is derived from Lucifer cipher. AES was designed by Vincent Rengen and John Deman. DES was designed by IBM. It is faster than AES algorithm is very faster than DES and DES algorithm is slower than AES algorithm. AES is a flexible algorithm and DES is not flexible as AES algorithm. AES algorithm is efficient with both hardware and software environment, but coming to the TES, it is very efficient only with the hardware. Thank you.